Yeah, that's well, welcome everybody. I am Mark Marquette, and you're here to stay curious with our friend today, Eric Baker. And we've had an interesting day here at the museum. Eric is always a reliable Friday docent. It's Worm Friday here at the American Space Museum. Some of us, including Anita, love wearing our worm shirts, and I got my beautiful. Actually, we did that to honor Karen Conklin, who passed away. She started wearing that. She looked a lot better in it than me. And then this is a shirt she gave me before the last Christmas before she passed away. Pretty cool shuttle
That's a
shirt
nice
there.
one. Yes.
So, and Eric has wore a shirt here to show the butterflies inside of his belly at the launch in the Launch Complex Center behind me here for a shuttle launch, which you participated in. How many? You think
100 plus.
100 plus of the 135. So really the green screen's reacting with him there, but that's what he's going to talk about today is the stress of launching a shuttle. And you've got all kinds of questions for him. I do too. So stay tuned for that. We were looking at the picture of these two legends. That is Charlie Mars, our godfather, and in the foreground over here is Mr. Jay Honeycutt. They both came in to see me at about the same time today. I didn't expect Charlie, but I knew Jay was coming in with a project we're working on. So these both gentlemen, in fact, Charlie just turned 90, so he's a nanogenarian, and Jay's an octogenarian. They look still pretty good, but I'll tell you what, they're sharp as can be. You talked to both of them today.
Yep.
How was that?
They were doing fine.
Yeah. What was Jay asking you? He's interested.
He was asking about that press conference they had about Artemis 3.
Oh, yeah. Right. Yeah. Yes. So big news, of course. Jared Isaacman taking full control of the Artemis situation and saying the whole architecture is wrong, including a 10-story rocket that's only, you know,
20
skinny as can be.
Not quite 30 feet wide.
Yeah, not quite 30 feet wide, 100 feet tall or more. So that's finally caught up with them. I call it a pie in the sky dream of Artemis before the end of the decade here will be a miracle to beat the Chinese because we're behind but we were behind with the lander, with the LEM, but it was in production and chosen and all that stuff. So we'll do a show on that next month or next week when the dew kind of settles on it, including maybe having Mike Leinbach here. What do you think about that, what Isaacman said? You're the space worker, not me.
It's all valid. You don't have a lander. They have a vehicle. It's a concept at the moment. It hasn't gotten into orbit yet, and the idea of landing it on the moon being taller than it's wide. Every vehicle, I mean, we've had like around 5 successful moon landings in the last couple of years.
Yeah.
All of the ones that were taller than they were wide fell over because the moon is not level.
No. And there's boulders and rocks and little tiny craters. And if you know your space history, and you do because you watch Stay Curious, you know that Apollo 15 particularly almost settled one leg into a crater that tipped it quite a bit. And I think 14 had a pretty big incline, didn't it, Marty? Marty's our expert on that, working on those lunar modules. But none of them were level. Anyway, I know that I think Apollo 11 was, anyway, one of them complained that it wasn't so level that they couldn't sleep because, they had their head down instead of up and all that stuff. So, but we're getting off track here. Another thing that happened this week, and oh my gosh, Marty says it weighs 38 pounds. Okay.
28.
48.
28.
Oh, 28 pounds. This is a frangible nut, a hold down nut for Mike Leinbach, launch director, in appreciation of his contribution to our nation's space program, given to him in February 1996, I guess it says there. And he is loaning this to our museum for us to put over there by our shuttle over there where we've got a hole nut. We've got the bolt.
Yeah.
And the bolt there has got, it's like welded on top. It's just almost melted down, that bolt that this nut was over. So explain this to us. What are we looking at here?
Well, each solid rocket motor is attached to the mobile launcher with 4 bolts and 4 nuts. And one of the nuts is called a frangible nut because it has a explosive charge on 2 sides. And at T0, they fire the solid rocket motors and they fire those nuts to split so that the vehicle can leave.
I didn't realize they were this heavy, and I thought they went in 4 pieces. But Mike explained it to me the other day, and some of them didn't split. Some of them didn't. The pyros didn't work. There's 8 of them, 4 on each.
Correct.
4 on each, and that's where you see the little cone, if you will, at the very base of the SRBs. That's
Right.
where they're contained, and that's where the capture mechanism is, right?
Correct. There's a capture mechanism on the part that goes with the solid rocket motor up,
Mm-hmm.
and down on the bottom, this would be like a bottom nut.
There's 2 nuts, more than 1 nut.
Yeah, there's a top and a bottom,
Okay.
and there's a catcher for the bottom one inside the mobile launcher.
Well, that is heavy. I'm telling you.
And
It
and
is.
and
Thank you there.
push a little farther forward
Put it
because
over there.
that is,
There. Center it there. So we got a frangible nut.
and
I
gravity's
talked to
not your
Chris-
friend.
No, I talked to Chris Callie last night. I said, I like props. I do. Nothing like good props. And we've always had this prop on our set since the beginning of Stay Curious. And next month we'll be celebrating 6 years.
Oh my
And
goodness.
we're so blessed that you and other people like you willing to spend a little time with us and talk about space history. So let's get into that a little bit here. Let's talk about, first of all, we're going to launch a rocket. We're going to launch the shuttle at 5 o'clock today, let's say. All right. So I want to know.
AM or PM?
At PM, 5
Okay.
o'clock here at the end of our show. It's 4 something now. So 5 p.m. in the afternoon, we're going to launch a rocket or a shuttle. So what time did you get to work? Did you sleep well? How nervous do you get? Do you even eat right? Type of thing. So how do you try to, what was your routine for over 100 launches, no matter what the time of day, of course?
I never had a problem sleeping myself. I basically, on some of the earlier launches that I sat in on, I found myself getting fairly nervous, and I said, well, why am I getting nervous? I mean, it's exciting, but you have to understand what you're doing. You have to trust all of the other people on the launch team, and you can only do your job. So as long as you're doing that, you know, you can.
Yeah, go ahead. You're getting some love there from
Yeah.
somebody.
Well, no, I was getting some spam.
Oh, okay.
But you can only do your job, and you do it as best you
There you
can, and you have to trust all the other members of the team. So the stress is still going to be there, but you just can't let it, drive you crazy. Now, we had members of our team in the office that I spent 25 years in that told the supervisor up front, I do not want to be on the T0 team. Put me on third shift, put me on 12-hour shifts somewhere else. Don't want to deal with it. And they never did. They were willing to. I thought it was pretty interesting. On a good day, on a good launch, there's actually less to do during terminal count than anywhere else during processing because you fixed everything, and as long as everything goes to plan, it's really quiet and boring. Now, as things get down to the last couple of minutes, you're sitting there going, okay, let's go. Don't want to come in tomorrow and do it again. So you can get a little of that excitement, but the the stress that you feel both during processing and during launch countdown is just as, did I look at everything? Is my part of the pie in good order?
Mm-hmm.
You know,
You
and
brought a big slice of your pie with you here.
I
We're
did
going to
bring.
see here in a minute. What are we looking at here?
This is a space shuttle firing room, and this is looking down from like the flight director's office that was on the fourth floor, looking down onto the third floor. And so he could look down at any time he wanted during processing or during a launch countdown if he hadn't come down to the his position yet. But you can see the horseshoes of the space shuttle firing room laid out with the banks of computer equipment behind them feeding the data into their displays.
Interesting there. And each one of those semicircles, horseshoe tape things, has a certain duty that they're watching, a certain aspect of the system, right?
Right, they're
And
broke down by
Marty
system.
is one of yours in here that he was a launch process service guy.
It was essentially next to Eric's.
You
I was
got
at
any
C12,
arrows?
you were at C13.
When I started, I was at the C12 console in the back of the room, and Marty at the time was working on the electronic engine interface units for the orbiter main engines, and that was part of DPS until he got transferred up to propulsion. And so we were in the back corner. Oh,
You can't see it.
yeah,
Where, way back here?
One set of consoles
Yeah.
back.
Okay. Well, very interesting there. What, all right, what did it sound like in there? I mean, was it
it was
noisy?
no,
Was it
no,
the level of ambient there? Just people, there weren't any typewriters clicking. I know that probably.
no.
Or computer keyboards clicking away, or
not really, because most of that's all the data's been entered.
now you're on a headset though too.
You're on a
right?
headset,
so you're not hearing the ambient room much.
Well, and you're on a specific channel, two specific channels. You're
Okay.
listening to your channel, and you're listening to the test conductor's channel.
Okay.
And so the test conductor is doing call outs, and you've got the launch countdown book in front of you, and you're going page by page, and you have already highlighted your things that you have to do. And so when you get to your point, if you have to have a call out to the crew, in our case, most of our stuff was early in the countdown for DPS because we had to do the initial program load of the flight computers with their software from the mass memory units on board,
Mm-hmm.
and set everything up for the rest of the count.
Mm-hmm. So what time we're launching at 5 p.m. here today? What times you get to work?
If I'm on the T0 team in a normal system, normally I'm going to be there at the beginning of my shift 8 hours beforehand.
Okay.
Now, when I eventually went over to test project engineering, and I was the vehicle lead for WV-103 for about 15 years. On those days when we were launching my vehicle, I would come in about 4 hours prior to T0 after tanking had already taken place,
Mm-hmm.
because they wanted certain members of the T0 team to be able to stay there, not have timed out at the end of their shift, so that if we scrub, you can stay there for the troubleshooting and the recovery and all the stuff you got to do to redo it all over again.
Mm-hmm.
Are you in a 24-hour scrub? Are you in a 48-hour? Or do you have to shut it down because you started the engines and then turn them off? In which case, you've got to do a couple weeks worth of
You
work.
said about 100 of the 135 launches. How does it feel to you, the number of scrubs that you had? Like half of them, a third?
Oh, no.
A quarter?
I think we only had about I don't even think we even had a dozen scrubs out of all the launches.
Really?
Yeah.
Okay.
It wasn't too bad.
Yeah.
The
Sometimes
I've sat through at least 3 myself.
Well, that's confidence. And,
Yeah.
we talked a little about Artemis 3 being pushed back in the whole architecture. And that's what Jared Isaacman, I think is showing his wisdom here that you need a cadence and you can't do 3.5 year cadence in between launches
Yeah,
and keep
that's
the team sharp as
yeah,
well as keep the team together.
yeah.
That's what he was pointing about. You can't do another launch 3.5 years from now. You're not going to have some people aren't going to stick around that are very valuable to the team now.
That's a valid point. The
So you had that going. The most shuttles launched in 1 year was 9.
correct.
Okay. But it seemed like generally there was 4 to 5, 5 or 6 a year on a steady pace there.
Yeah, once we gotten going and things had settled down after Challenger.
Uh-huh. Well, we're talking with Eric Baker here, where I see a lot of wonderful people watching us on Friday here. Rosalie, Jubilee, she's in first, and then mostly Park's beside her there. Marion, and we got Ophelia is in France. Hi, young lady. Man Space, we got Mitch Rothman is from Lake Wales. And we're moving the meeting to Tuesday, Marty, are we not, for Shuttlefest?
Yes, we
And
are.
he must not know about it yet. So we'll talk about that on the phone, Mitch. Steve Jokums is up there cranking out decals of shuttle space station. Of shuttle tile underbellies and space station um, solar panels. And Matt Pike says, I think what everybody's kind of feeling. Glad to see NASA returning to common sense. An opinion about today's press conference that's gone viral. Is that a good assessment, Eric?
It
What is
depends.
common sense?
Well, it's common sense from are we due to the system we work under every 4 years, we may or may not change
Yeah,
administrations.
political system.
And so what's the new priority going to be? We've tried to I lived in a blessed time in the fact that my entire engineering career was spent on one program that lasted 30 years. So even with the disasters that we had, we still were moving forward, launching vehicles. And so it's whenever you bring up a new program, you've got to have the finances down, you've got to have a specific mission in mind, and then you have to have the political will to keep at it.
Mm-hmm.
One of the nice things about the commercial crew program was that they're trying to turn over most of that to the commercial side. Now NASA is a research based organization. Their job is to do cutting edge stuff, but they still have to have specific missions approved for a long enough period of time for them to be accomplished. If you get them into, if you start them, change administrations, cancel them, start them, cancel them, nothing's going to get done. So
Yeah, that's where China and Russia had an advantage. In China now, they don't have the political switch over. The money's there, and they're getting their country behind them there. So we're going to get into this some of the things that Eric went through as a test project engineer. Want to just say hi to Fred Kleiner's watching from Silicon Valley. Ashley Kendrick, grandma to my grandbabies there. She says hey from Upper East Tennessee. Janet Gretsch is watching. And it's 7 in the morning down there in Pomona, Australia, where they're having cakes and bacon and some maybe juice there. Cliff Watson, good to see you watching today there. So let's everybody at your job might have a little thing in your drawer that pertains to your career. All right. And I was in the news business. We had a thesaurus and the Associated Press manual of officially
style guide.
Yeah, exactly. the style manual. Part of the AP style was employee was spelt with one E, not two. Things like that are in there. But you have something very cool that you brought with you that is your little cheat notes there. Hold it up there for us all to see.
Well, we're
Yeah,
going
I got a
to.
picture of it too, but there you go. There it is.
Now that is a 3-inch binder.
Go ahead and show it up there for it, Ken, if you don't mind.
Not at all.
Yeah.
It weighs almost as much as a frangible
Yeah,
nut.
it does really.
So you can check
Yeah.
the weight.
Yeah, no, it is, and chock full of what you expect an engineer has is his favorite things to just at the moment lift up there. When I wrote a column for 22 years every week in a newspaper, I had on one side of me was everything about astronomy books and my quickie thing, and over here was my manned space stuff that were so valuable to me to fact check and so forth. So that's yours there. It looks like this inside of it there. So
Now the thing that you get taught in engineering is that you cannot memorize all of the stuff that you're going to be working with. A
Okay.
mechanical engineer, electronics engineer, an electrical engineer, a chemical engineer has a vast number of basically reference books and tables and guides and strength of materials and stuff like that. So on the space shuttle, we were system engineers and processing engineers. And so we had to take in a great amount of information. When you first hired in, you spent almost 2 weeks just going to classes about all the things that can kill you at Kennedy Space Center.
really,
High pressure gas from 100 pounds psi to 700 pounds psi. What is that? If that gas cable is not secured properly, it'll whip around and cut your leg off.
mm-hmm.
And then it'll asphyxiate you because it's broken and it's spewing helium or nitrogen. The propellants, is it cryogenic? It's super cold. It'll burn you. Is it anhydrous ammonia for the cooling system? It'll poison you. Is it monomethylhydrazine? It'll kill you in parts per million. So they spend a couple weeks just hammering into you. Don't touch that. If you hear this siren go off, you go in this direction. And so it automatically builds up a stress level that you know. Don't stand under a suspended load. It's a 250-ton crane, so it might drop 250 tons worth of whatever it's lifting on you. So they do that, and then you start learning your system.
Mm-hmm.
And to become a test project engineer at the time, you had to have at least 5 years experience within one of the space shuttle subsystems. And then you could go over to integration console.
What was yours?
I spent 4.5 years in DPS, taking care of the orbiter
DPS.
data processing system,
Okay.
taking
Right.
care of the orbiter main computers and the flight displays and the robot arm.
Boy, you just constantly had upgrades all the time about things.
Well, and they
you dealt with the arm too?
yes, we did.
Yeah. Did you deal with Art Edwards? Our
Yes,
good
yeah,
friend
Art
here?
was he sat next to me
Yeah.
for a number of years and then became the supervisor.
Well, I just saw Art yesterday,
Yeah.
so we'll get you guys together one day. That might be a fun show.
But when you became a test project engineer, you had to then learn in more detail up to 4 more systems,
Mm-hmm.
because the things that if you go onto the pictures.
Yeah, we're gonna look at some of your pictures here. By the way, before I get too far away from it, just a shout out to all you Dilbert fans like Eric out there. Okay, the cartoon, and there's some more of his Bible, if you would. We all have that business thing there. So now we're getting into your little minutia here.
This is a cover page for the data bank.
Mhm.
And this was basically all of the measurements, ground measurements, flight hardware measurements, and there was a whole system of keeping track of those. But this page right here just told you how many ways could they send that data down from the orbiter to the ground. And it had all the different formats and things like that.
Okay. And we got another.
Now here is just a
Don't
list.
expect you all to read this. It impresses upon you of
Right.
things that.
These are the things that we had to be able to monitor on a day-to-day basis for the various subsystems. And then there's a second page to this.
Uh-huh.
Now you go to the next page. This is a breakdown of those function designators. These are the bits of data. Is this a temperature? Is it a switch? What system does it belong to? And so
Propulsion, mechanical, electrical power generation on the bottom here, but at the top it says function designators, field descriptions, definitions. Field 1, major element. Field 2, subsystem member, general.
major element is like V for vehicle,
Okay.
orbiter vehicle. S is for, or B is for booster. T is for tank. G is for ground support equipment.
Things that you are going through in a systematic way
Right.
at a certain time frame with the test conductor in charge of it with the
Well,
the launch
basically,
director.
all of this data is there so that if you have a problem during a countdown or
Mhm.
during day-to-day processing, they will say, I'm getting this measurement is out of limits.
Okay.
And so just by looking at it, you say, okay, how many FDs are we looking at? Do we have to start a data retrieval so that we can get some timeline on, when did it start to fail? What is it now? And that's all gets folded into the troubleshooting plan. As a test project engineer, I had to sign off on every single troubleshooting plan our vehicle had, on my shift. And so we had to be familiar with all of this information.
Mm-hmm.
You didn't memorize it per se, but you got to the point where you had seen it so many times. And when you're monitoring, you're not actually testing something yourself. You're overseeing everything that's going on around you in the firing room. If you go to the next,
Let's talk. I want to ask you first here. How many times did you rehearse this? How many? You had the wet dress rehearsal.
now for countdown specifics, you basically you would have the wet CDDT countdown dress rehearsal Su-17 S0017.
Oh yeah, I remember the Su-17.
Su-7 is
That's
the countdown number.
Yeah.
17 is CDDT. And then there was a version of it where you would do a CDDT for every flight, but you would only do a wet one for the first flight of that vehicle.
Okay.
Or if there was some major system problem that drove you to a second wet CDDT.
We're talking about launching a space shuttle at 5 o'clock today, and we're in the launch control. That this is the outside of it, next to the VA.
Now this picture right here, this is an actual hard copy from a display, and this is for the Environmental Control and Life Support System Monitor. This basically is the overview for ECLSS, the cooling folks, and life support folks with some of the ground equipment and the temperatures coming out of it, and then the temperatures inside the vehicle. And we had these really old, it was a wet process printer at the back of each console that had a liquid toner in it, had Fram filters on it. It was big rolls of this chemically treated paper, and they would print out, and you would tear them off and let them dry.
Yeah, I've seen that kind of,
But
like a mimeograph machine.
The top two lines of that screen are just chock-a-block full of all sorts of information. It has what day of the year is it on the Julian calendar. That's what the 246 is for.
The Julian calendar.
Yeah,
wow.
Then you have the time in GMT. Then you have generally like what console you're at and what firing room are you in. The second line has various indicators of what program are you looking at the moment, and what program is running. Uh, there's and that's just the background data that you have to know.
Tom Celentano points out that all this technical data and so forth, it seems so overwhelming.
Well, and that's one of the things that can drive the stress. Now, you're looking at all this stuff, and you spend about a year doing just on-the-job training yourself in the subsystem. And then, like when I became a test project engineer, I had a leg up on other subsystem engineers because I came out of DPS. DPS, data processing, processes the data for everybody.
So you're used to seeing the jumbles of data
Yes.
and
I'm
reading
I'm
through it.
I'm used to seeing, massive amounts of information. Now, generally, just like anything else, if it's green on the screen, you're okay. If it has gone yellow or red, that's going to, attract your attention. And you're going to say, well, is that because we're doing something and we know why it's green? Is it did it warn us in the procedure we're running or monitoring? Or does someone say, OTC, DPS, we've
Uh,
got a failure on this, that, or the other thing?
Fred Kleiner's got an analogy here, maybe. So you plug your automotive OBD2 probe in under the dashboard, like you do your car.
Yeah,
That's sort of what you're doing to the space shuttle to check out all the parameters.
exactly. If you
Good analogy there.
if you
Fred.
go to the next
Yeah,
screen.
let's go to
This is a broad-based pictorial of the
environmental control.
showing the
What's
water
the L mean?
water cooling
LCL, ECL,
ECLSS, environmental control and life support
and
subsystem.
life support systems. Okay.
So that is showing the freon cooling loops, the water cooling loops, the O2, the N2 tanks. It shows the humidity separator. It might show the potty on there, but that's just a broad brush of one subsystem. If you go to the next,
We want to just break up the mash of numbers there to show you again inside. This is more modernized in the later years.
in the later years, we this was the pretty fire room that we did all the launches from, and it had the new cabinet tree. And the new, well, each room had new computers, but they only put the fancy cabinets in fire room 4.
All right, the cool mahogany look there to calm you down there as you're, it did get, somewhat stressful, like you said. Was there a point where they locked the doors?
Yes,
That they don't let anybody in?
Yes, they did. And it was spelled out in the firing room. You knew it was coming, and everybody went out and had their last potty break.
Potty break, and there was a cigarette area probably.
Well,
back in the day.
Well, early on, they smoked in the firing room.
Oh, don't say that. Okay.
They had ashtrays on the consoles.
Yeah.
And
not at Marty's ashtray, not at Marty's console, I'll tell you that right now.
when he went from C12 up to C3,
yeah,
they had a group of guys there. It looked like there was a forest fire.
Is that right?
Of smoke rising above them.
I've got tales of that in the newsroom with editors coming in with 3 packs.
Oh, yeah.
And a coffee in the other, and ashtrays would be full at the end of the night, and about 10 coffee mugs piled up.
That was, and in the fire room early on, that was one of the few places you could have a lighter.
Oh, really?
You could not have a lighter or matches in the vehicle assembly building because it was an ordnance area.
Yeah.
Because the solid rocket motors.
All right. You all got some questions out there? Throw them at us here, but I think we got our usual group having a great time on a Friday fellowship here on Stay Curious.
But I wanted you to go to the next picture.
Sure, Eric. There we are.
That one right there, and blow that up. This is talking about where the data comes from.
Vehicle GSE LBD interfaces. So GSE is ground system equipment, right?
launch data bus.
And launch data bus. Bus is the
So this is
electrical.
this is basically the command path. This is what allowed us to send commands up to the vehicle, whether it was, in the hangar, the data is coming out from the instrumentation system
Uh-huh.
and is through hard lines, through the umbilicals, eventually to LPS in the firing. I mean,
You can
you'll see the
solid
console,
rocket boosters,
right,
obviously, on each side
right,
there.
but you can see at the bottom it says the console.
Uh-huh.
So that's the command path for two-way communication. Where
Wow.
but this is how we send commands up from the consoles into the orbiter. And
There, okay. Interfaces, of
and
course.
one of the things that you had to do was those interfaces are broken at T0. The big umbilicals pull out, they go
Okay.
down into the tail service mass, and they had two special boxes called DBIAs, data bus isolation amplifiers.
Uh-huh.
And they made it so that when you pulled those plugs, you could still use the launch data bus on board the vehicle because it was used by RMS and it was used as the vehicle went up the hill, so that you didn't have an antenna. If you have an unterminated wire, it acts like an antenna, will pick up all sorts of
Right.
electromagnetic noise. So those DBIAs that talk to the orbiter data bus and then got over to the solid rocket motors through the ET umbilicals
Now,
were very important.
You were talking about the where these wires are at, or the launch pad. It looks like two tombstones
Yeah,
behind the back of the shuttle SRBs there.
correct. And
That is
that is an electrical, it's a fluid, and it's a pneumatic connection. So that's where the liquid oxygen goes in, the liquid hydrogen goes in. This is where the purge air goes in.
You had another name for them.
The T0 masts.
No, yeah, right. The mast, yeah, right, yeah. So that's what the tombstones are that are
Correct.
there. That's filled with the
Connections.
interface electronics that this is all about.
Well, the part of it is electrical,
Uh-huh.
but those plates that press up against the sides of the orbiter
Yeah.
also have the fluid, cryogenics, and the pneumatic connection. So it's everything.
Okay.
And when they pull out, big armored doors slam down because a big plume of fire is going to go by.
Exactly. All right. Carrying on here, radiation.
We had antennas everywhere, and we had this is part of the safety stuff that we had to learn, and this is basically all the types of ionizing radiation, EMF signals for radio, for navigation. In the payload bay, once the payload bay doors open, a little dish antenna pops out and allows you to talk to the ground or talk to a satellite that goes to the ground. But you got to test all that stuff in the hangar. And on some of these, you're talking hundreds of watts. And so you're talking ionizing radiation. It's like getting an X-ray continuously. Don't stand here. Yellow tape, is blocking this off. Why can't I get to my workstation? They're doing a radiation test. Come back after lunch.
Okay.
So this is another layer of the things that'll kill you.
Well, that you have to know. When you lock the doors and everyone's got to go to the bathroom break, is that T minus 30 minutes?
When did they? It was a couple hours. You had it was
couple
like
hours
after.
So
After tanking was done,
after that either.
Yeah. Well, you did it, and you had bladder control.
Yeah, right. We're not going to talk about that, all right? But I'm always curious about getting to work on time with the infrastructure of you've got thousands of people driving, wanting to see the launch and so forth. And back in the day, the causeways had drawbridges. They
Yeah.
just got the last causeway that doesn't have a drawbridge on the 405 going to Kennedy down.
Yeah,
So did you ever worry about
there-
that, to getting caught in the traffic?
well, you just made sure that you.
Then
Now, when I first started, I was living in Cape Canaveral, and so I came in over on the Air Force side, and kind of the back way,
not as
and
much
so
traffic
that
way.
wasn't too bad. But generally, it was really only a problem if there was a scrub, and you had to get home so you could, get some sleep, especially if it was a third shift terminal countdown,
Yeah.
and so that you could, start your timers all over again.
Well, let's get more into this before we've got a couple good comments. Tom Celentano again says he was anxious enough just watching it on TV. Okay, he can't imagine the feeling of being in the fire room. And Steve Jokums is enjoying the show. He says our episodes with the shuttle space team are some of the best, and we appreciate that. But we more appreciate those team members like Eric that are willing to spend a little time with us here and spend time actually little pre-production putting the Eric shows together, because that's something that's way outside of my wheelhouse. Like, what the heck is this all about?
No, this is
The
basically.
aft avionic bays. Now that's the aft of the orbiter.
That's right. This is where the main engines are.
Okay.
So there are basically three areas that are like big boxes that have the equipment that lives in the aft, and this is a set of multiplex, demultiplexers, and various other control boxes for talking to the equipment and the systems in the aft compartment. That's the behind the back wall of the payload bay.
Okay.
So, and one of them is actually sitting what would be on the floor of the aft, and the other two are kind of up more vertical on either side by the 50-1 and 50-2 doors, which are where the techs would have access to get in there during processing.
Now, part of your job to take a field trip and go see the physical
yes,
hardware.
there was
GSE or not grounds, not just
Yeah.
not, but our orbiter.
Yeah,
hardware
but
too.
this is orbiter hardware.
Yeah,
This
okay.
is in the vehicle.
'Cause you're describing it, so I
Yeah.
know that you saw it. So
But so yeah,
that's interesting.
You-
I find that very
you-
interesting. And then,
especially because in DPS I had stuff everywhere. I had stuff in the cockpit. I had stuff in the mid deck. Like here we have Avionics Space 3 and 4, and this is on the aft wall of the mid deck, which is the bottom floor of the crew compartment. And this has a couple of the one of the computers, GPC-5 lived in there, and a raft of other electronics.
I see the potty there to the right there.
Yeah.
The schematic right there. And it certainly had its share of electronics and
Well,
things
that's
like that.
mostly pneumatics.
Pneumatics. Okay, pneumatics. Yes.
They
air
they
pressure.
controlled all that with airflow.
Yeah. Marty, we doing okay over there? Surely have a great group watching today on our Fellowship Friday here on Stay Curious. CT Cubing said he kind of hints he might have wore astronaut diapers there in the LCC the last hour maybe of the countdown if you can't get out
Yeah,
to go to the
but
bathroom.
again, we'd been doing it for a while, and
yeah, everybody knew what to do.
everybody knew what was expected.
Yeah. All right, and holy cow, more avionics.
This
in
is
bays 1 and
avionic
2.
bays 1 and 2, and these were on the forward wall of the lower deck of the crew
So
compartment.
this is moving the surfaces of the shuttle.
Well, this is like the ground or the GPCs, the general purpose computers.
Uh-huh.
These are what are sending the actual commands through the MDMs, through the various data buses, to the end items to move the hydraulic actuators X amount in whatever direction, depending on what you had just asked the.
Okay. Very good.
But we had
one
to
of these boxes represents.
Various, well, a lot of it was DPS, but you had radios, you had gyroscopes, you had TACANs, you had flight control equipment,
Now, what about your communication with the commander and the pilot up there?
Now on the ground,
They're doing things that you're telling them to do, or not you per se, but you're going up the chain and you have to be telling the commander and the pilot what's going.
during launch countdown, you're talking to what is called a spacecraft operator. And as you get deeper in the
We need
countdown,
one of those on our show.
those
several around.
those become astronaut support personnel. These are astronauts who were not flying that day, but they are responding. And after you've done the countdown switch list, that's where you've gone through every single switch in the orbiter and put it
8
in
hours before, 5 hours before.
thereabouts.
Okay.
It's like in the second or third day. Takes a couple hours.
Okay.
They have two teams, one working on the flight deck on two channels, a couple people downstairs. There's not as many switches down there, but still, it takes an hour or two to go through the the flight
Okay.
switch list, and those are the people that put it into that final position as the test conductors call them out. Those are astronauts. During normal processing, we have techs called spacecraft operators.
Mm-hmm.
Mr. Winkle was an SCO on the lunar module early in his career. And
He
so
certainly was. That's right.
we had one of our TPEs that we had. He had a degree in aeronautical engineering, but when he first came to the Space Center, he specifically said he wanted to be an SCO. I said, well, you got a degree, you're an engineer. Says, if you don't let me be an SCO, I'll just go somewhere else and do something else.
Spacecraft operator.
And so for a number of years, about half of his career, he was an SCO. And his name is Bobby Dawes.
Okay.
But he then eventually became a test project engineer. And so he did it both. But he really wanted to be at that human interface in the crew modules.
And like Marty was on the lunar module, in gosh, half a century ago, Marty. And so, hope you're enjoying this as much as I. That's why I've been interrupting you with some questions there, because I don't want to not forget to ask them. But I'm fascinated by guys like Eric that are the front lines of the final everything before launch. So we got a couple more charts here to show.
Now,
Here's
this picture is kind of fun. Now, this, even up on the flight deck,
which you recognize the cabin of the crew.
And then you have the two slots where the commander would be on the left and the pilot would be on the right.
Mm-hmm.
And that's kind of fun because there are no co-pilots in outer space.
That's correct, yeah.
Because all of those astronauts that are pilots or commanders were test pilots. And so in their test pilot career, they became, pilot in command of whatever, and they were not going back to being a co-pilot.
A co-pilot, exactly.
If you even go back and look at the three members of the Apollo team, you had the mission commander, you had the command module pilot, and you had the lunar module pilot.
Yeah.
But those two were the co-pilots.
Yeah.
Commander was the pilot.
Yes.
But they didn't like
the
co-pilot name,
co-pilot at all,
and they got rid of it.
The commander's the one that's doing all the flying in the left seat.
But this little chart just shows some of the terminal electronics that are driving their displays, and then you can see the actual inertial measurement units, the IMUs. These are the gyroscopes that provide the measurements to the computers saying where is the orbiter now and how fast is it going. And basically, when it's on the pad, that has been measured, to a gnat's hair.
Gnat's hair, I like that.
Of position, so that when it lifts off, the stresses on those gyroscopes are fed back at a specific rate,
Wow.
and that's all part of an inertial measurement unit. And that's how you fly. That's how you had any kind of precision flying uh, before GPS. You had an inert, you could have systems like TACAN and VOR,
Yeah.
variable omni range
The
on
cue ball
airplanes.
on the Saturn V rocket was important for its directional.
Well, we had
a
an
great
80,
tip.
we had an ADI, an attitude director, on the orbiter, and it was the big 8 ball, kind of thing. But the IMUs did not need any external signals. Now they are subject to drift, and so they like to have other systems to be able to update them, like the star tracker and various other things. But those IMUs were developed on some of the very, very early programs, from like the inertial compass, where you had a gyroscope so that you could fly over the north and south poles, because a magnetic compass won't work anymore because it's just going to spin. It doesn't know where the hell it is.
Mm-hmm.
But a lot of those early systems came from the old Navajo program, which was an early
Oh, really?
cruise
The
missile.
Never Go Navajo.
That's right.
Yeah.
And well, and they had the misfortune of developing most of the major systems that we used later in the space program, because the Air Force kept changing the requirements.
Yeah.
And they went from a short range to a medium range to a long range
Yeah,
cruise
Navajo,
missile.
a real legacy rocket out there, Cape Canaveral.
But they developed the inertial guidance systems that they used on the nuclear submarines and the Atlas and all the later rockets. So it was a tremendously important program for the stuff they learned, and it ended up on the space shuttle too.
Well, I'm fascinated with this. Hope that you are. So we're down to about, 5 minutes or something before launch here. Mike Leinbach, the launch director of 31 Shuttles, is going to come on and start doing some Stay Curious episodes with us. And we left the other day over lunch. He was telling me that Charlie Blackwell Thompson had an important job as his deputy launch director back in the day. She gave a call out. I wonder if you remember it, Eric. She gave a call out at about 2 minutes. Birds are go. Do you remember that call out? She had to monitor any flock of birds that would be flying over the launch pad before the launch. And he said that she actually gave a call out to him on the headset. Birds are go.
You do know we launched a bat.
Yes, I do. I forget which one, but you don't remember the birds are go?
I don't really remember the birds or go.
Okay.
But
they've had.
But the launch
things.
director is basically the one that, well, when Bob Seek was our launch director for so many years,
Yes, 51 shuttles.
they were referred to as Go Bobs.
Oh, really?
Because he would call out all the test conductors, the payload test conductor, the tank test conductor, and the meteorology, range safety.
Tell me now.
Says,
let's go.
It says, and they would say Go Bob.
Go Bob.
And
Go
so
Bob.
we called him Go Bobs.
Go Bob. What a great guy, Bob
Seek.
Seek, yes, Seek.
What's our question?
Yeah, go ahead, Marty.
James Gibson is asking, did the shuttle twang at liftoff affect those hold-down bolts? Was the twang known for the first launch?
Yes. They, as a matter of fact, they tested it to a certain extent with like big hydraulic come-alongs in the vehicle assembly building prior to STS-1. They pulled on it to get some kind of idea of how much twang they were going to get. And then, of course, we had an FRF. In addition to a wet CDDT, they had a flight readiness firing for every orbiter during the its processing at the pad for the first flight. That's where they fire the engines for 20 seconds.
Mm-hmm.
And that's what you see during a normal countdown. You'll see the vehicle push, and then it'll just respond and push back, saying, "I don't like that."
Comes back, and then
then they lift off. But for 20 seconds, you got like a permanent twang.
Good question. We're in the launch control room here, and we all know, if because everybody's super smart out there watching Stay Curious, Eric, that at 31 seconds is the handover to the onboard computers. What is that like sitting in your desk in the LCC, your station?
For me, that's kind of the relief point. You know, you've gotten past all the you pick up the count at T minus 9 minutes. You've gone through all the terminal stuff. You've started.
You had a
started
hold, an automatic hold for half
Right.
hour or so there at T minus 9,
Right.
for everything to catch up. Is that
Correct.
Okay.
Any built-in hold is there to do catch-up stuff and resolve any problems. But when you pick up at T minus 9, you're in terminal count, and things start happening that will determine whether you get to launch that day. At 5 minutes, you start the auxiliary power units for the hydraulics
Okay.
on the orbiters, and then closer down, you start the same HPUs on the solid rocket motors, because they have each one their separate hydraulic systems, because they have thrust vectoring on those big engines,
Correct.
and because the nozzles are
Move
movable.
The nozzles, yeah.
And then you get down to you pressurize the tanks, you retract the umbilicals. At 31 seconds,
Beanie cap.
beanie cap is gone. At 31 seconds, all the busy work is done, and you're just starting to get ready to start flowing propellant.
How long does that 31 seconds feel when you're really?
It varies from person to person. Mr. Winkle indicated he thought every second was like 5 minutes.
Okay.
I just like to watch it click off. And then when you got down to 6 seconds.
Were you watching a master clock in the ball?
We really couldn't see that. There was a big clock up front, but on the every screen, there's a countdown clock right there.
Okay.
And it's just ticking down. And some of the displays had built-in countdown clocks, but you just sit there and just watch the seconds fall away. At T minus, 6.6 seconds that they light the mains.
Yeah.
And they verify, 50 milliseconds apart or thereabouts. And if they're all good, you can see the shock diamonds form. You say, "Ooh, we're getting close," and then you hit T0 and you're flying.
You have a video coming into the launch LCC also.
All of the consoles had small black and white monitors.
Okay.
And usually had one on the engines.
And then at 0, bingo, there you got it. Outside the window. All you can do is just look up, right?
Yep.
Nothing. You're done your job. You can't do anything about anything now. You just sit there and however, what did you do? Did you think about the people on top up there? Did you sit back satisfaction that
it's
it was
basically,
a good
congratulate everybody around you. You're still looking at stuff. You've handed over control at Tower Clear to JSC.
Correct, yes.
But
you're still looking at stuff after
right
turned over to Houston.
All the ground support equipment, like for main propulsion and those guys, they've got all sorts of securing that has to be done. But for the most part, especially at integration console at T0, my work was done for the day, especially once they said negative return.
Mm-hmm. All right, Marty's holding up the sign there. So he's got something on that UCX family microphone on this excellent program by Eric Baker today.
Yeah, just getting back to twang. The twang was deflected about 25 inches, but it was also used to calculate when the main engine would fire. It was a factor in the main engine firing to make sure it got back to 0.
Well, the main engines of fire, that's what causes the twang.
Right, but also the duration
right,
of the main engine. If it lifted off prior to a certain time, it would not be back at 0. It had to get back to 0 before liftoff.
The twang.
It deflected 25.5 inches, actually.
Well, you've only got 6 seconds, less than 6 seconds, because you started the engines. I don't know the numbers for that. But they do want it to come back as much as possible when they at T0 when they light the solids.
Yeah, so it comes back to point zero.
Yeah.
But that was factored into the duration of the main engine firing.
Okay.
Yeah.
Two engineers here talking to each other. Love it. Love it. And the twang is an important thing of this. The twang, the seesaw back of the engine.
Because
whole
the
stack.
space shuttle is not symmetrical in its thrust.
Mhm.
You're sitting on a tripod of fire.
Yeah,
Two big ones and then a small fire for the main engines.
there you go. Well, I've certainly enjoyed this, and we are so pleased that Eric has actually given our museum something that is in this firing room here. And Marty, if you would go up to the Discovery in the middle there of the 5 and point to the profile of Discovery coming right at you there, OV 103, which was your baby.
Mm-hmm.
Okay. So you all see the inside profile there. What's that? What are we looking at, Eric?
Well, that is basically a picture of 103 orbiter on a sheet of like poster board, display board, and it's actually part of a bigger display, and so it's like Velcroed on there, so it sticks out a little bit, a little 3D effect.
So you took that off of there, and that's
Well,
where that is there.
The
That's in the center. Of
Mike
the center
Line
poster
when
there.
when they put this display up in Farnham 4, Mike Leinbach said that this particular picture was too dark, and so they reshot it, and on the back of that picture is signatures of all the main personnel, administrators,
Should take a picture of
engineers,
that. We'll show it another time.
but and so we had to go in and sign the new one that's up in Farnham 4 even today. When we had finished signing the new one, I said to one of my NASA counterparts, "What are they doing with this one?" And she said, "I don't know." And I said, "Can I have it?" "Sure." So I took it home,
Yeah,
and then I framed it up so you could see both sides.
yeah.
And my lovely wife said, "You can't hang that in the house. It's enormous." So it lived behind a headboard for a number of years until I ran into Charlie Mars here at the museum one day. He says, "Charlie, I've got this. It used to hang in Farnham 4 for a couple flights. You know, it's all ready for display. If I give it to the museum, will you hang it up?" And he says, "Sure."
Yeah.
And so that's just one of the many space artifacts, how they get here.
Yep, I like it too. It's one of my favorite things here. It's got a 3D feel, and you can look through it, and it's just really a fun little piece here that you don't have. Well, it's an original piece that you'll never see in any other museum.
Exactly.
There's so many unique things here. By the way, come on Fridays. Eric's a hell of a docent. We had good group in here today, didn't
We had
we?
folks from Australia. We had folks from Tampa. We had folks from all over.
Delaware. I talked
Yeah.
to a couple from Delaware today, and we're very blessed. We're getting the tourism season's just cranking up. So, well, thank you a lot here for a great job today. We got people all over the country. Why don't you give out the shout outs to them there watching today?
Okay, RG Jubilee,
That's Rosalie.
mostly parked. Ophelia Sauterelle,
She's in Toulouse,
Mitch-
France.
Mitch Rothman, Steve Jochum, Tom Celentano, Matt Pike, Tom Uziak, Alan Schmidt, Carlton Bailey, Cliff Watson, Janet Creech, Ashley Kendrick from Tennessee,
Yeah.
Fred Kilner in Silicon Valley, C.T. Cubing or Cubbing, Waktube,
Mm-hmm.
and Cedar Quest, and James Gibson.
Yeah, great, everybody there. Thank you for watching today. Hope you, many of you expressed how much they enjoy having our space workers on here, and as our ace volunteer, Connie McDaniel's been helping get some of the regular guests lined up for March. So we've got 7 or 8 of them already lined up, including Carlton Bailey, scheduled to be here on Tuesday, March 3rd. So, CB, we'll just have a nice chit chat about the state of affairs and stuff going on there. And bring us some of your streak shots too there. He's a good streaker out there at the rocket launches there. So, let's see. Cliff, yeah, I think you did meet Eric. Cliff down in Australia there. Remember meeting the Australian chap here? He's been here for 2 different, he's been here
I
to
see.
America twice. He
Yeah.
came during the eclipses, but he was, we did 4 shows with him here. So, Marty, anything to button up over there on our Streamlabs production? I'm going to give you one more shot of this franginal bolt before
Just don't drop it on your foot.
I tell you, it would bruise it for sure. God, it's so cool. Think of the engineering of designing this and cutting that out and so forth and so on. Thank you, Mike Leinbach, for all you do to support the museum. And just talking about us, Eric, like you do, is also a great benefit to our numbers here. So, and Alan Schmidt, just a shout out to him. We had a couple misinformation things on yesterday's show with Gary Allgaier, and I kind of pointed them out in the comments there on our YouTube channel. Nonetheless, it was a great show. We talked about the Gemini 10 wonderful missions in the 60s. You'll want to go check that out, as well as if you like what Eric did today, put his name in the search engine there with that little magnifying glass and see some of the other programs that Eric's done for us here. It's always very unique, and you make some complicated things very simple to understand, Eric.
Well, thank you very much.
Thank you very much for your dedication to the American Space Museum and your support of Stay Curious. So we're putting another week in the system, another week of episodes up here. We're up to 1,460, I think. And we'll be hitting 1,500 here pretty soon, probably, I figure around April 1st. So we're just steady as we go here. Like I said, getting more guests lined up. And even may have an astronaut pop in here or have a recorded show. We got a couple recorded shows we're going to do also. So look forward to that, y'all. I look forward to you staying curious with us here at the American Space Museum. Thank you, Marty, for all that you do to support the museum. Eric is just one of another 10 docents out there that give us time every week. If you're local and want to give us 4 hours a month, we'd certainly love to have you help out here at our museum. So until next time, I'm Mark Marquette, wishing you all to have a wonderful spacey weekend, and I'll see you next week to bridge that space between us.